Every evening, as the sky deepens from blue to black and the first stars puncture the veil of daylight, we look up. We ask the oldest question, not just about our own lives, but about the canvas itself. What will the universe do tomorrow? For millennia, we assumed the heavens were eternal, unchanging, perfect. But the universe, like us, has restless nights. It expands, it screams in radio silence, it births suns and swallows them whole. This is perhaps the biggest mystery for all mankind, not what we will become, but what the cosmos has in store for its next sunrise. Look at the night sky. It feels permanent, doesn't it? The constellations, Orion, Cassiopeia, the Big Dipper, have looked the same for every human who ever lived, but that is an illusion of our short lives. The universe's tomorrow operates on a scale that crushes the human imagination. When we say tomorrow in cosmic terms, we mean a billion years from now, or 10 billion, or the heat death of eternity. We can't help but wonder, is the universe getting older and wiser, like a tired old man? Or is it still a chaotic child, throwing tantrums in the form of gamma ray bursts and black hole mergers? Everyone would like to look a couple of days or a couple of billion years ahead into the future and see what the cosmos will look like. Will there be new stars? Will the galaxies still spin? Or is something truly painful waiting to happen to the fabric of reality itself? What's the worst that could happen to a galaxy? People worry about asteroids or climate change, but a galaxy? The worst that could happen to a galaxy is solitude. Right now, we live in the Milky Way, a swirling metropolis of 100 billion stars. Our nearest galactic neighbor, Andromeda, is 2.5 million light-years away. But here is the mystery of tomorrow. Andromeda is falling toward us, not slowly like a leaf in autumn, violently, at 110 kilometers per second. In approximately 4.5 billion years, which on a cosmic clock is essentially tomorrow afternoon, Andromeda will collide with the Milky Way. The two titans will tear each other apart. Gravity will fling stars into intergalactic voids. Our beautiful spiral arms will unravel. The night sky, if any life remains to see it, will look like a blender full of fire. But here's the strangest part of the mystery. That isn't the worst thing. That is salvation. Because without that collision, the Milky Way would eventually run out of gas to make new stars. The collision will reignite the cosmos. Out of death comes a new elliptical galaxy. Astronomers have already named it Milkdromeda. But let us look deeper, past the stars, past the galaxies. Let us look at the stuff between things. For the last century, we have realized that everything we see, every planet, every star, every black hole, every nebula, makes up only 5% of the universe. 5%. The rest is a ghost story. We call it dark matter and dark energy, but those are just names we gave to our ignorance. Dark matter is the scaffolding upon which all galaxies hang. It is invisible, it does not reflect light, it does not emit radiation. We only know it exists because the stars spin too fast, as if some enormous silent hand is holding them in place. What will happen to dark matter tomorrow? We don't even know what it is today. It could be a particle we haven't discovered. It could be a gravitational echo from another dimension. Every evening as we prepare to rest, physicists go to sleep haunted by this question. Is dark matter stable? Because if dark matter decays, if it has a half-life, then the scaffolding of the universe will collapse. Tomorrow, in the cosmic sense, the galaxies might simply fall apart, like a cathedral whose mortar suddenly turns to dust. And then there is dark energy. This is the true villain of the mystery. In the 20th century, we discovered the universe is expanding. We assumed gravity would slow that expansion down. Like a ball thrown in the air, we expected it to eventually fall back. But in the 1990s, we looked at distant supernovae, the ghostly candles of the cosmos, and we realized something terrifying. The ball is not slowing down, it is speeding up. Dark energy is a property of empty space itself. As the universe gets bigger, more empty space appears. More dark energy means faster expansion. This is a runaway process. What will tomorrow bring? If dark energy continues as we think, the future is bleak. Distant galaxies will accelerate away from us faster than the speed of light, not because they are moving through space, but because space itself is stretching. Eventually, the Milky Way will find itself alone in an infinite void. No other stars will be visible in the night sky. Our descendants, if any exist, will look up and see nothing but blackness. They will have no evidence that the Big Bang ever happened. They will think the universe is just one lonely island of light in an endless cold ocean. That is one possible tomorrow. But let us ask the question again with a shiver. What's the worst that could happen? Death. Death shall ultimately claim all structures, not just humans, not just planets, but atoms. There is a hypothetical end called the Big Rip. If dark energy is not constant, if it grows stronger over time, the acceleration will not stop at pushing galaxies apart. It will push solar systems apart. It will push planets away from their stars. Then it will push molecules apart. Then atoms. In the final moments of the Big Rip, the fabric of space-time itself will stretch faster than the speed of light. Atomic nuclei will be torn apart. Protons and neutrons will disintegrate. Even the quarks inside them will be ripped asunder. There will be no explosion, no fire, just a silent, infinite tearing. No one currently in recorded history, no star, no galaxy, no black hole has cheated this fate if the Big Rip is real. No matter how much the universe tries to avoid it or delay it, entropy will come to us all eventually. But here is the mystery within the mystery. We don't know if that will happen. We don't know the nature of dark energy. It might be weak. It might be a cosmological constant that never changes. Or it might get tired. It might reverse.
What if the universe is breathing? Some theories suggest that dark energy will eventually weaken. Gravity will win the ancient tug-of-war. The expansion will stop. And then the universe will fall back inward. We call this the Big Crunch. Billions of years from now, galaxies will start rushing toward each other. The cosmic microwave background, the faint afterglow of the Big Bang, will shift from radio waves to visible light to gamma rays. The sky will become a furnace. As the universe collapses into a singularity, an infinitely dense, infinitely hot point, time itself will lose its meaning. Space will cease to exist. But here is the most beautiful mystery of all. If the universe collapses, it might not be the end. It might be a reset. When a star dies, it explodes and seeds the next generation of stars. When a universe dies, it might bounce. The Big Crunch becomes the Big Bang of a new cosmos, a new universe born from the ashes of the old, with new laws of physics, new constants, new possibilities. Our universe, with its stars and galaxies and life, might just be one heartbeat in an eternal cosmic rhythm, a big bounce. Tomorrow, in the deepest sense, might be the birth of everything again. But let us not get ahead of ourselves. Let us talk about a quieter, more patient end, the end of matter itself. You are made of atoms. Atoms are made of protons, neutrons, and electrons. Electrons appear to be immortal, but protons? We're not sure. The standard model of particle physics suggests the proton is stable, it will last forever. But grand unified theories, the attempts to merge quantum mechanics with relativity, suggest that protons might decay. Their half-life is incomprehensibly long, something like 10 to the 34 years. That is a 1 followed by 34 zeros. To put that in perspective, the current age of the universe is 1.4 times 10 to the 9 years. A proton would live a trillion times longer than the universe has existed so far. But eventually, if protons decay, every atom in the universe will dissolve. The iron in your blood, the carbon in the stars, the silicon in the rocks. Everything will become a thin soup of leptons and photons. No molecules, no chemistry, no life. just a cold, dark, dilute fog expanding forever. That is the heat death, the most likely tomorrow according to current data. The universe fades to black. The temperature drops to just a fraction of a degree above absolute zero. Nothing happens, and then for eternity, nothing continues to happen. In this heat death scenario, only the black holes remain. These are the ghosts of dead stars. They do not evaporate quickly. They will feast on the fading radiation. They will merge and grow. For a time, the universe will be a graveyard of singularities. But even black holes are not eternal. Stephen Hawking discovered that black holes evaporate. They emit a trickle of radiation, Hawking radiation, so slow that it takes 10 to 100 years for a supermassive black hole to vanish. When the last black hole evaporates, it will not go quietly. In its final second, it will release as much energy as 1,000,000 hydrogen bombs, a final flash of light in the infinite darkness, the last firework of the universe. And then what? Silence, emptiness, a universe at maximum entropy, no gradients, no energy, no time, just flatness. But physics is not done with the mystery, because even nothing might not be stable. Quantum mechanics tells us that empty space is not truly empty. It seethes with virtual particles, fleeting sparks of existence that pop into being and annihilate a moment later. This is called quantum foam. In a dead, heat-dead universe, after trillions upon trillions of years, something impossible might happen. A quantum fluctuation, a random, spontaneous bubble of low-entropy space, a new Big Bang. This is called Boltzmann brain, or vacuum decay. It suggests that the universe's tomorrow is not linear, it's cyclical on a scale so vast that we can't even write the number of zeros. The dead universe waits, and waits, and waits, and then, by pure chance, a new cosmos is born. Our universe, with its stars and galaxies and life, might just be one heartbeat in an eternal cosmic rhythm, a big bounce. Tomorrow, in the deepest sense, might be the birth of everything again.
Every evening, as we prepare to rest, we ask this question to ourselves. It is perhaps the biggest mystery for all mankind and for the universe itself. Why is there a cosmos at all? Why are there laws of physics? Why do stars shine? Why do galaxies dance? Why does anything exist when nothing would be so much simpler? The universe is under no obligation to make sense to us, and yet here we are. Small, fragile, temporary creatures made of stardust, looking up at the same stars that will eventually swallow our planet. We are the universe's way of asking questions about itself. We worry about the uncertainties that may lie ahead, but the universe does not worry. It simply is. It expands, cools, forms structures, destroys them, and waits. So what will the universe do tomorrow? The honest answer is terrifying and beautiful. We don't know. We don't know if dark energy will rip us apart. We don't know if protons decay. We don't know if the big bounce is real. We don't know if we live in a multiverse where every possible tomorrow happens somewhere. But that mystery is the greatest gift, because a universe without mystery is a dead universe. A universe where we already know the ending is a story not worth telling. Tomorrow, the universe will continue to do what it has always done, surprise us. A supernova will go unnoticed in a distant galaxy. A black hole will be born. A star system will form planets. And somewhere, perhaps, on a small, wet world orbiting a yellow dwarf, a creature will look up at the night sky and ask the same question we ask tonight. What happens next? And the universe, in its infinite silence, will whisper back, "Let's find out together."